All right, so here in 5.1, we're going to introduce to you polar coordinates, okay? So it's going to be an entirely new way of representing a point, and we'll look at converting back and forth between polar coordinates and what we call rectangular coordinates, x and y coordinates that we're used to working with, okay? And then we'll give you a brief taste into some rectangular equations that are written in polar form so you can see what those look like, okay? All right, so consider a point P in the polar coordinate system. It's represented as an ordered pair. The ordered pair is made up of an r value and a theta value. R is going to correspond to a radius of a circle. Theta is going to be an angle, obviously, which you can represent in degrees or radians, okay? All right, now in the polar coordinate system, you have the polar axis. It's the ray whose vertex is at the pole, and the pole is the point at the origin. It coincides with the origin, okay? So think polar axis is a lot like the x-axis, coincides with that, and again, pole coincides with the origin. All right, so I have a point plotted below, point P with coordinates r, theta. So I would draw my angle theta. Its initial side I'm going to place on the polar axis, okay? The vertex of the angle is at the pole, which I'm designating with an O here. And then the terminal side of the angle is where r comes into play. So I draw out theta, and then off the terminal side, I go r units from the pole along that terminal side, and that's where I would place the point, okay? Now, if your r value is negative, notice what you have to do here to plot the point. You rotate to the terminal side of theta, and then you would extend theta in the opposite direction, okay? So if this is the angle theta right here, that's your terminal side, right? You're going to extend it in the other direction, and you're going to go r units off that side to get to your point P. Okay, so let's illustrate this a few times. Let's let this load. Okay. All right, so currently I have r set at 3, and I have theta at a nice easy angle measure of pi. So what I'm going to do is start at the polar axis. Okay, now this illustration, it has the polar grid behind it, and we'll talk about that a little bit more in a minute here, but polar axis is where my initial side of my angle is. I'm going to rotate to pi for the terminal side of the angle. And then off the terminal side from the pole, I'm going to move 1, 2, 3 units. Okay, and I would place the point there. Notice that point, it's on the circle there. That would be a circle of radius 3. R is 3. Okay. All right, now let's consider, what if I make r a negative value? Maybe I'll make it -2. So I rotate to pi again, but instead of going 2 units on the terminal side of pi, I go backwards 2 units in the opposite direction. And that's where I would place my point. Okay? All right, so let's draw some ourselves. We're going to do these without the grid right now, and this is how you're going to want to do it on the homework problems. Okay, 3 pi. We actually just did that one on the illustration here. So give me the initial side of your angle, which would be the polar axis. Okay, and you're going to rotate to pi, the terminal side of it. And then you got to envision, if the terminal side were, evenly divided by units of 1, we would just move to the third spot on the terminal side. That's where the point goes. How about 3 pi over 6? So initial side along the polar axis. Draw out pi over 6, which is 30 degrees. And along that terminal side, go 3 units. There would be your point. How about -3? 3 pi over 4. Okay, so you draw out 3 pi over 4, which is 135 degrees. And with r being negative, what you're going to do is extend the terminal side of that angle in the opposite direction. And along that, you're going to move 3 units. So it's like you're going backwards 3. All right, and then 2, 0, meaning 2 for r, 0 for theta, 0 radians. So think if your angle is 0, the initial side and the terminal side are the same, right? So you can stay on the polar axis, move 2 units along it. There's your point. And that does coincide with the rectangular point where x is 2 and y is 0. Okay. All right, so now let's talk more about the polar grid that you briefly saw in that illustration. So this is used to plot your polar coordinates and graph your equations. We'll use this a lot more in the coming days. So big thing to understand, this grid system, it coincides with the rectangular coordinate system, okay? So the polar grid, it's not like it's separate from the rectangular grid, okay? This is just a different way of plotting points in 2 dimensions, okay? The grid is made up of concentric circles, and they're all centered at the pole, okay? So in the grid here, you see this circle right here would be considered a circle of radius 1. The next one, this would be circle of radius 2, etc. You also have some lines in there that are labeled with angles, right? So we typically do this in increments of 15 degrees, right there, all the way around, the circle, okay? All right, so let's say I want to plot 4 pi for point A there. So here's my polar axis. I rotate to pi, and from the pole, I'm going to move to the 4th circle, okay, where r would be 4. That would be the location of point A. All right, point B, 4 pi over 3. So I start at the polar axis, rotate to 4 pi over 3. From the pole, I move 4 units to the 4th circle, where r would be 4. Right there. And then for point C, notice the r value is negative. So I'm going to rotate to the angle pi over 6. Okay, here's the terminal side of it, right? But with r being negative, I need to extend that in the opposite direction. So I'm going to use the line here that's labeled with 7 pi over 6. Okay, along that, I'm going to go 3 units in that direction. And there would be point C. Questions on plotting points? Okay, so now let's talk about the fact that we're dealing with angles here. There's an infinite number of coterminal angles that represent the same location. So that means that any point that's given in polar form, there's an infinite number of coordinates that can be used to express that point. okay? So let's say you're working with the point r theta. R is positive. If you want another set of coordinates to represent that same location, all you'd have to do is take theta and add a multiple of 2 pi to it. You agree if I add or subtract a multiple of 2 pi to theta, I'm just going to end up on the same terminal side of that angle? Okay. Now, let's say you want to take the initial point with a positive r value and you want to rewrite it with a negative r value. That means we've got to go in the opposite direction of the terminal side of theta, right? So what we can do there is add a multiple of pi or subtract a multiple of pi, which is essentially what this is stating right there. You take theta, you add pi to it, and then from there, you can add any other multiple of 2 pi, and you'll still be coterminal to that spot. All right? So let's plot 5 pi over 3, and then we'll get 2 more sets of coordinates to represent the same point. So 5 pi over 3 is 300 degrees, right? That puts you in the 4th quadrant. Okay? We're going to move to the 5th circle. 1, 2, 3, 4, 5. So right there's the point we're working with. Okay, so what I could do is I could take that, and if I want to keep r positive, all I need to do is add 2 pi to it to get another set of coordinates that represents the same thing. And we agree if I'm here at 5 pi over 3 and then I add 2 pi, that just gives me 1 full revolution and I'm back where I started. Okay? So I would need common denominator there. 2 pi is 6 pi over 3. Add it with the 5 pi over 3, you get, that would be 11 pi over 3. Understand, that is not the only answer I could give. There's an infinite number of answers that could be given here. You could add or subtract any multiple of 2 pi. Okay? Now, let's say I want to make r negative to represent this point. Okay, so we'll start with 5 pi over 3. And if I want to make r negative, all I have to do is maybe subtract just pi. Okay. Just think, if I'm at 5 pi over 3 and I subtract pi, that's going to take me back to right there, which would be at 2 pi over 3. And would you agree that if I go to 2 pi over 3, with r being negative here, I've got to go backwards in the opposite direction, and that'll still take me to the point that's in blue there. All right. Now let's spend some time looking at how we can convert back and forth between polar coordinates and rectangular coordinates. Here's where a lot of the trig comes into play. Okay, so again, understand a point that's represented in polar form, it has an equivalent rectangular form with x and y coordinates associated with it. All right, so I have point P plotted there with coordinates r theta. If you just draw a right triangle associated with theta there, the legs of that triangle would be the x coordinate and the y coordinate of that point in rectangular form. So do a little bit of right triangle trig with theta. Isn't cosine of theta x over r? So we'll solve that for x. That means x would equal r cosine theta. And then sine of theta would be y over r. Solve that for y. You get that to equal r sine theta. So these are like our conversion equations that help us go back and forth between the two forms. So let's go from polar to rectangular first. To me, this is the easier direction, all right? So x equals 8 times the cosine of 5 pi over 3. Okay, now cosine of 5 pi over 3 is 1/2. If you need to, you could draw a reference triangle to help you visualize that. 5 pi over 3 is the same as 300 degrees. So that puts you in the 4th quadrant, right? So there's your 5 pi over 3, or 300 degrees, which means the reference angle here is 60 degrees, making my values associated with the triangle here negative radical 3, 1, and 2. Well, cosine off of that, x over r would be 1/2 then. 8 times 1/2 is, of course, 4. So that works out nicely. Y, though, we're going to have to give a radical within our answer. It would be 8 times sine of 5 pi over 3, which would be 8 times negative radical 3 over 2. And that's going to simplify to negative 4 radical 3. So I can say that the polar set of coordinates, 8, 5 pi over 3, represents the same point as the rectangular set of coordinates for negative 4 radical 3. That's an r and a theta. This is an x and a y. Now, I found an applet that is a nice visual of this. And it shows both coordinate systems overlaid with one another. So it shows that they're coinciding with each other. Okay, so if I click that box, that allows me to plot this point in terms of the polar coordinates. So I want 8, 5 pi over 3 right there. Okay, now they're representing it as 8, negative 60 degrees. Isn't negative 60 degrees coterminal to 300 degrees? Okay. And then look at the rectangular set of coordinates that are given. 4, comma, negative 6.93. Negative 6.93 is just the approximation for negative 4 radical 3. Okay. All right. Yes?
Can you go back to example 3 real quick?
Sure.
So like, they're like, for example, like, on the first one you said like 5, and then, is that 11 pi over 3?
Yes.
So like, you know how we did the thing where we added the 2 pi right here?
Mm-hmm.
On the test, would you want us to make that like 2 pi over, like 2 pi over 1, and then you have to like add this to this and then make it like a single fraction? Or is it fine if we just say plus 2 pi?
I want you to actually simplify it out, yeah. Yeah, for sure. Okay. So now let's go in the other direction. To me, this is the more difficult one, to go from rectangular to polar. Okay, now, we saw that there's an infinite number of ways that we can represent the point in polar form, right? Since we have an infinite number of coterminal angles. Because of that, I'm going to put this stipulation on theta. We want to give our answer so that theta is between 0 and 2 pi. Or if we were working in degrees, between 0 and 360 degrees. Okay? All right. With that in mind, notice what's in red there. Plot the point that you're working with so you know what quadrant you're in. And when you go to give your final answer, the angle that you're giving, it better be between 0 and 2 pi, and it better represent a point that is in the quadrant that you've plotted. Like the terminal side of that angle better be in the same quadrant as the point you're working with. Okay? Now this first one's not too bad. So if I plot 2, negative 2, that's going to put me in the 4th quadrant, right? X is 2, Y is negative 2. This is the angle that I'm after, theta, expressed positively, and I want my R value. Well, the R is really easy to get. Just use x squared plus y squared equals r squared, Pythagorean theorem. So that's going to be 2 squared plus negative 2 squared equals r squared. R squared will equal 8, which is 2 radical 2, right? Okay, now, I think it's easy on this triangle to reason out the reference angle. The legs of the triangle are the same, right? So what's that mean the reference angle is? 45 degrees. Okay, so I'm going to give the radian version of that, pi over 4. Okay, now is pi over 4 in the fourth quadrant though, like this point is? No, it's not. So what do I need to do with this pi over 4 to bring it into the fourth quadrant?
Subtract it from 2 pi?
Yeah, really you should be subtracting it from 2 pi. So I could say theta is 2 pi minus pi over 4, which would give me 7 pi over 4. Okay. So my answer, I'm going to say that 2 negative 2 in rectangular form is the same as 2 radical 2, 7 pi over 4 in polar form. Okay, now here's another way you could approach this. You know, suppose you didn't recognize that the reference angle there was a nice 45 degrees. You could use the inverse tangent function to get theta, but you got to be careful about it. If I took inverse tangent of y over x, and then I go to my calculator, what we have to remember from our trig course is that the inverse tangent function only will give you outputs that are in quadrant 1 or 4. There's a restriction on the inverse tangent function to make it 1 to 1. So it's only going to give you quadrant 1 or quadrant 4 angles. And if you remember, the quadrant 4 angle is going to be expressed negatively. So if I pull out the calculator and I do inverse tangent of negative pi over 4, or I'm sorry, of negative 2 over 2, or simply negative 1, it gives me negative 45 degrees, or there's the radian version. Okay? The issue with that is it's not in the interval 0 to 2 pi that we were asked to be in, right? So we have to be mindful of that. And to bring it into the interval, I'd have to add 2 pi. There we go, 5.49 approximately. That's the approximation for 7 pi over 4. Okay, you can verify that. Boom. Okay, so if you're going to do it that way, you would have to add 2 pi to this, right? The calculator is going to give you negative pi over 4. Adding 2 pi gets you the 7 pi over 4 that you're after. Okay, now let's do the next one. Negative 3, 5 puts you in the second quadrant. And this is the angle theta that I'm after. Okay, so let's get r first. X squared plus y squared equals r squared. That's negative 3 squared plus y squared equals, or plus 5 squared equals r squared. R squared is going to be 34. R is radical 34. Okay. Okay, now let's get theta. I'm going to take inverse tangent of -5/3. And if I put that into my calculator, that is going to give me a fourth quadrant number again. That's the radian measure of it. That's not very concrete. There's the degree measure. Can we agree that's in the fourth quadrant? Is our point in the fourth quadrant, though? No, it's in the second quadrant. So what we need to do in this case is take this result and we need to add pi to it to bring it into the second quadrant. Okay, so I end up with 2.111 approximately. So I'm going to say that -3.5 in rectangular converts to radical 34, 2.111 approximately in the polar form. All right. Example 6, let's give you a quick taste of an equation that's in polar form. We want to convert it to rectangular form. Well, consider what equations we do have that relate polar and rectangular. We got Pythagorean theorem, and we have these two new ones we just came up with today. So r equals 6 cosine theta. To get that to rectangular form, maybe I multiply both sides by r. That'll give me r squared equals 6r cosine theta. R squared can now convert to x squared plus y squared. R cosine can become x. Now I'm technically in rectangular form, although that doesn't mean too much to me. So I'm going to algebraically manipulate this. I'm going to subtract the 6x over, set up a blank for completing the square. 9 is what completes the square. I can factor. I've got x minus 3 squared added with y squared equals 9. Does that look familiar? What is that an equation of? That is a circle with a center of 3, 0 and a radius of 3, yes? Okay, so anytime I see an equation in polar form of r equals a number times cosine or sine, I'm going to know that that's an equation of a circle now. Okay, we'll look more at those in the days to come. All right, and then the last one, we're going in the other direction. 4xy equals 9, that's rectangular form. It's a rational function. I want to go to polar form. So I replace x with r cosine. I replace y with r sine. And then I manipulate this. This is r squared, 4 cosine theta, sine theta. So I just kind of rearrange things there. And then I can divide that whole set of parentheses over to get r squared alone. And you're not really used to polar equations yet, but this is an acceptable end. Usually you want to solve your equation for r or r squared at the very least, like we've done here. Again, we'll look more at these in the days to come so you get more familiar with them.